Haugen. I'm Director of Product and Technology Development here at Flow Sciences Incorporated in Leland, North Carolina. I've been working on fume hoods, similar but not exactly the same as this brand new Safety Flow fume hood, for over 30 years. And in the last decade particularly, I've been asked by a lot of people who are designing new laboratories for a fume hood with better safety and at the same time the ability to exhaust a lot less air. The whole idea of using airflow to contain and remove contaminants from experiments is not new. But as energy costs have increased, the price we pay for this containing stream of air has gotten much higher, requiring us to modify and rethink the containment process. The Safety Flow fume hood can reduce this energy consumption by 62% over traditional fume hoods. But so can any other manufacturer's hood by simply lowering their specified sash opening and face velocity. Here's the real question. Can this lower exhaust volume and face velocity contain fumes effectively? Many purported high-efficiency hoods have failed the ASHRAE 110 containment test when challenged. This graph is from an independent University of Texas Austin test of several high-efficiency hoods in 2008. Most of the hood containment lines ran very high when the hood was challenged with a 30 foot per minute cross draft. We have to be very sure an energy-saving hood does not do this. To establish demonstrable containment in real-world conditions, redesign of the hood exhaust approach from the inside out is necessary for containment and lower exhaust to happen simultaneously. Let's see why energy conservation requires design changes in hoods. The cutaway graphic shown here illustrates how a classical older bypass hood works. Our new high containment Safety Flow chemical fume hood takes a step forward from the partial bypass technology. We call it the overlapping sash bypass, or OSB. This design has a fixed front to back gap at all sash positions, but alters the air path from twisted to straighter as the sash is lowered. This alternating path yields the benefits of a bypass but offers an additional bonus. Air that was formerly shunted through the hood top immediately into the building exhaust now does work, being sent along the sash interior and then sent rearward by the flange at the topmost position of the sash opening to help push the fumes rearward. Thus, less total air does more work and actively helps contain fumes. Another feature that helps do more with less is the new rear lower baffle, which integrates vertical with horizontal baffle slots. Most hoods still use horizontal slots only. We find that such a system amplifies a phenomenon called the hood vortex, a tumbling and turbulent motion that harms the ability of the hood to contain fumes, particularly near the sash opening at low velocity. The Safety Flow therefore uses a network of performance elements including the sash flange, the overlapping sash bypass, and vertical and horizontal slotted baffles. All these items are not isolated features, but an integrated system of complementary parts that produces fantastic containment. We use the ASHRAE 110 1995 fume hood containment test to evaluate whether our low-volume fume hood actually contains fumes. Here's Dr. Alan Goodman, our containment laboratory manager, to describe the test.
Hello, I'm Dr. Alan Goodman. I'm the laboratory manager here at Flow Sciences, and I'm here today to tell you about the ASHRAE 110 1995 testing that we've performed on the Safety Flow fume hood under its low flow setting of 60 feet per minute and at a sash opening of 18 inches. The ASHRAE 110 standard consists of three main components: a face velocity measurement, a smoke visualization test, and a tracer gas challenge. The smoke test consists of a simple flow visualization and a large volume challenge. These tests are designed to verify adequate capture and retention of vapor into the enclosure. For the small volume test, we use a small smoke generator such as a wizard stick. and evaluate the air movement through the face opening and into the enclosure. We ensure that we have nice smooth flow of air through the enclosure with no significant reversions. The large volume visualization test is designed to assess the ability to retain the vapors inside the enclosure and visualize turbulent or dead air spaces that may be present. For this, we use a theatrical smoke generator and to release a large volume of smoke into the enclosure, and then we'll monitor the enclosure to ensure that there is no escape of the smoke through the face opening. Additionally, we look at how long it takes to clear the enclosure once the smoke has been turned off. The tracer gas is a highly sensitive method of determining the level of vapor retention in the enclosure. For this, we use sulfur hexafluoride as a tracer gas, and the gas is diffused into the enclosure at a rate of 4 litres per minute. Using the mannequin as a human substitute, measurements are taken for 5 minutes at each test location within the enclosure. The accepted upper level of tracer gas outside the enclosure is 50 parts per billion, as defined by the ANSI AIHA Z9.5 recommended practice. For all our third-party tests, we also use the ASHRAE equipment in the HAM or Human as Mannequin test. In this test, the ASHRAE diffuser emits tracer gas while actually surrounded by equipment which is manipulated during the test. Flow Sciences has third-party tested the safety flow fume hood at 100 feet per minute, 80 feet per minute, and the low flow scenario depicted here at 60 feet per minute and at 18-inch sash opening. In all of these tests, the safety flow hood showed containment at or below 10 parts per billion in the breathing zone at 100, 80 and 60 feet per minute. We invite anyone interested in reviewing these outstanding results to contact us, and we will send you a copy.
Thanks, Alan. So the Safety Flow Fume Hood provides an exceptionally safe containment system, even while exhausting far less air than a standard chemical fume hood. It does this containment feat by using a synergistic system of features that work together, putting every CFM of bypass to work. We invite you to watch our other fume hood videos, which go into great detail about how much energy these lower face velocities can save and extra exciting features in this brand new chemical fume hood. We are also encouraging you to call or email us whenever your lab planning focuses on good fume hood containment at a very low cost of ownership. I'm Dr. Bob Haugen, and I remind you of an important partnership just waiting to happen. You pay for the air, we put it to work.